Lesson 8.2, Factoring by Grouping. In the last lesson, we factored out the greatest common factor, and in this lesson, we're going to take that a step further and we're going to factor polynomials by grouping. So when a polynomial has 4 or more terms, we factor it by grouping. So factoring by grouping involves the following steps. First, we factor out the greatest common factor if necessary. So far I have an 8, a 20, a 12, and a 30. Each of these will divide by 2. I do not have p's in every term, so I can only factor out the 2. That leaves me with 4p to the third plus 10p squared plus 6p plus 15. The next thing I do is I arrange the polynomial so that the terms with commonalities are grouped together. Now in this case, there's a couple different ways I could arrange this. 4 and 10 have a 2 in common, and then they both have 2 p's in common. 6 and 15 have a 3 in common. I could move the 10p and the 6p, switch their places, because 10 and 15 have a 5 in common, and 4 and 6 have a 2 in common. Or I can leave it as it is. I'm going to leave this as it is. Now I factor the GCF out of each group. So what I want to do is I split the 4 terms into 2 sets of 2. So I have this first group, and then I have a second group. Now that I've split this into groups, I look at the 4p and the 10p, 4p to the third and 10p squared. They have a 2 in common and 2 p's. Now if I take that 2p, the 2 p's away and the 2, 4 divided by 2 is 2. There were 3 p's. I've taken away 2. I have 1 left. 10 divided by 2 is 5. There were 2 p's. I took them both away, so there's none left. Then I look at the second group. 6 and 15 both divide by 3. 6 divided by 3 is 2. And there's 1 p. 15 divided by 3 is 5. Now, if you've done this correctly, what you'll end up with are 2 parts that match in parentheses, 2p plus 5 and 2p plus 5. What I do next is I take the terms outside of the parentheses and I make that one set of parentheses, and then the matching parentheses becomes the second set of parentheses. And now this is completely factored. We factored out the GCF again, the GCF being 2p plus 5. So here are some examples. 3n to the third minus 4n squared and 9n minus 12. If I split this here, I have, first of all, I check to see if there's a greatest common factor of all the terms, and there was not. Then I split it. Between the 3 and the 4, I can't take anything out for those, but n to the third and n squared, I can take out 2 n's, leaving me with 3n minus 4. Between the 9 and the 12, I can take out a 3. 9 divided by 3 is 3, so that leaves me with 3n minus 4. These match, so I take the terms outside of the parentheses, and then I take the parentheses. Okay. Looking at this one, I don't have a greatest common factor in common, so I split it in half. There are 2 m's in common here, so I take 2 out. That leaves me with 1 m. Now I took the 2 m's away, so when that happens, I have to put a 1 there as a placeholder. 2m and minus 2, I can divide both by 2, and that leaves me with m minus 1. They match, so I have m squared plus 2 and m minus 1. (35xy minus 5x) and 56y plus 8. I can keep these x's together because they have a 5 and an x in common. Or I can move this to put the y with the x because they'd have a y in common. And then 56 and 8 have an 8 in common, so I'm actually going to leave this like this. Oops. 35 and 5 both divide by 5, and they have an x in common. That leaves me with 7y minus 1. And then if I take 8 from both of these, I get negative 7y plus 1. Now when this happens, what you want to do is you want to take out a negative 8 instead of a positive 8. If I make that 8 negative, I've pulled out a negative 8, and that makes negative 56 divided by negative 8 gives me a positive 7, and 8 divided by negative 8 gives me a negative 1. Now they match. So when you have the same numbers but opposite signs, pull out a negative. And I have 5x minus 8 and 7y minus 1. Try these three. You're going to have probably a large number here. Check to see, you've got a 21 last, so check to see if 224, 56, and 84 will divide by 7 or 3 to see if you can factor that out. So go ahead and pause the video and try these three, and then when you're finished, unpause the video and we'll check your work to see how you did. Okay, as I was factoring these, I realized I probably should have told you what to do when nothing would come out. You pull out a 1, so you end up with 4n squared plus 1 times 3n plus 1. Here, I factored out a 5n and a 3, and I got 5n plus 3 times n minus 2. And this one, a 7 came out of every term, leaving me with 32az plus 8ac minus 12yz minus yc. When I pull out 8a out of both of these terms, I get 4z plus c. If I pulled out a positive 3 from both of these terms, these would both be negative. So instead I pulled out a negative 3y, leaving me with 4z plus c, which gave me 7 times 8a minus 3y times 4z plus c. Let's try a few more. I have 192, 72, 24, and 9. Now I know 24 does not divide by 9, but it does divide by 3. So I'm going to try 192 and 72 divided by 3. And 192 divided by 3 leaves me with 64x squared y. Oh, I just caught myself. Every term has an x in it, so I'm going to pull out a 3 and an x, leaving me with 64xy plus 72 divided by 3 is 24, so 24, and there are 2 x's left because I took a 1 away. 24 divided by 3 is 8, and there's an r and a y, and then 9 divided by 3 is 3, and there's an r and an x. Now from the 64 and the 24, I can divide an 8, which will leave me with 8. I can also take an x. That leaves me with 8y plus 3x. And from 8 and 3, I can't take anything, but they're both negative, so I'll pull out a negative 1, and I'll pull out an r, leaving me with 8y and 3x. So this will factor to 3x times 8x minus r times 8y plus 3x. From 90, 36, 150, and 60, I believe I can take out a 6. They don't have any letters in common other than, for all four of them. Okay, 90 divided by 6 is 15. 36 divided by 6 is 6. 150 divided by 6 is 25. And 60 divided by 6 is 10. From 15 AU and 6 AU, I can pull out a 3A, which leaves me with, 3AU, which leaves me with, that's AV. Hold on one second, let me fix that. I wrote out over my v, and so then I thought it was a u. So I can pull out a 3a, which leaves me with 5u minus 2v. And from 25 and 10, I could pull out a 5, which would give me a negative 5u. So I'm going to pull out a negative 5 to give me a positive 5u and negative 2v. So now I have 6 times 3a minus 5y times 5u minus 2v. From our next example, 3 of my terms have an a, but one of them doesn't, so I can't pull out an a. I have a 140, a 60, a 168, and a 72. I know they'll all divide by 2. If I divide by 2, I'm going to have a 70, a 30, an 84, and a 36, which tells me since they're all still even, I could go further and divide by 4. If I divide by 4, I'll have 35, 15, 42, and 18. None of these will divide by all of the same thing, so I know I can pull out a 4. So I get 35ab minus 15a squared plus 42b minus 18a. I'll split these in half here. 35 and 15 both divide by 5, and I can take an a from each of them. That leaves me with 7b minus 3a. 42 and 18 both divide by 6, and that will leave me with 7b minus 3a. Sorry, there should be a plus there. So I'll have 4 times 5a plus 6 times 7b minus 3a. So why don't you try the next 3, pause the video, and when you've finished, unpause and come back and check your work. Okay, the first one was fairly straightforward, but in the second and third you did have to remember to rearrange the polynomial to put the terms together that had something in common. So when I factored out my 8x, I got 2xc plus yd minus 2xd minus yc. These two terms have nothing in common, and neither do these, but if I rearrange it, I switch these in order and put 2xd with xc, I can pull out a 2x. And then I have yd with yc, I can pull out a y. And that allows me to finish the factoring. The same thing occurred here, where I had to switch these two. And then I also switched the order here so that I got 5z minus 4c. And then I was able to factor that completely.